The Pandas Concat function can be used to combine two series or data frame objects on a specified axis and has the power to add hierarchy to the resulting object. To use the concat function, we will create a new script with the pandas library imported as PD. Next, we will create two new series objects to concatenate together. Suppose we tracked our time for each lap while running around a track over 2 different days and recorded this information in a series. The first series will be called Tuesday, and it will contain a dictionary with the keys lap 1, lap 2, lap 3, and lap 4, with the values 130, 135, 120, and 140. The second series will be called Wednesday, and will contain the same keys as the Tuesday series, but the values will be changed to 120, 115, 130, and 120. Next, we will create a new variable called laps and set this equal to pd.concat. Within the concat function, we will add our two series objects within a list as the first argument. When the result is printed to the console, we see the Wednesday series has added to the end of the Tuesday series, and the index from each series has been maintained. If we wanted all the laps to be on the same index, we could tell the concat function to ignore the index from the original series objects with the ignore index keyword and assign a value of true. When the result is printed to the console, we see that the index now contains index values from 0 through 7. For now, we will use the original index for each containing the lap numbers by removing the ignore index keyword. Next, we can provide another level of hierarchy on the data using the keys keyword and assigning a list within the values Tuesday and Wednesday separated by a comma. When the result is printed to the console, we see that the two series objects are separated by day, with each day containing the lap times from a single series object. In addition to series objects, the concat function can be used to concatenate pandas data frames. To do this, we will create two new data frames that represent different people running 3 laps on the track. The first data frame will be called John, and it will contain the first 3 lap times from the Tuesday series above. The column name will be John, and the index will be the names of each lap. We will repeat this for our second runner with a data frame called Ashley, which will contain the first 3 lap times from the Wednesday series above. Now we can join these two data frames as a new data frame called runners by using pd.concat with a list containing the John and Ashley data frames as the first argument. When the result is printed to the console, we see that the index from each data frame has been maintained and the Ashley data frame has been added onto the end of the John data frame. However, we would like the resulting data frame to have the same index for both runners. To do this, we can add the axis keyword to the concat function and specify a value of 1 to indicate we want to concatenate the columns and not the rows. The resulting data frame now contains the same index for both runners. What if Ashley ran one more lap than John and we tried to combine the data frames? We will add lap 4 to the index of the Ashley data frame and specify a 4th lap time of 115 in the list of values. Now when the concat function is used, we will see the index has added the lap 4 value in the 4th row, and the John column has a value of nan for this row. This is because the default join operation for the concat function is an outer join, which will return the overlapping rows between the two data frames, and fill in the rows that are not contained in both data frames with nan values. To return the rows that are shared between the two data frames, we can add the join keyword and specify the value of inner, which will only return the shared rows lap 1, lap 2, and lap 3, even though the Ashley data frame contains a value in the lap 4 row. For more Python tutorials, like, share, and subscribe to the PyPros channel.